Okay, so let's do the first one here. I don't know. Okay, so the first one I have here is given the function. So let me write down the function. F of x equals x squared plus x minus 10, x squared minus x minus 14. Express a domain using interval notation. So this will be defined everywhere except do you want to go over this one? Oh, okay. Ah, yes, yes, that was correct. It is not factorable. So I could change it to something that is factorable if you wish. Okay, yeah, so I'll just sort of change this to a say 7 and a 2, so that make this a 5, a 7, a 5 and a 2, make that a okay, so let's change this. So that'll be a minus 7 plus 2, and then this would be a plus 5. Oh, so make that actually a minus 3 maybe. Okay, so let's slightly change it. So then it will uh, be easier to look at things. Okay, so what? Oh, we do want an oblique asymptote, so I will make it into this. I'll make it this way. Okay, so let's factor this. So it'll be x plus 5, x minus 2 over x minus 7, x plus 2. Okay, good. So there everything factors. So A, express the domain using interval notation. So let's do the domain. And so let's set the denominator to 0. So it's defined everywhere except when the denominator is 0. So I'll set the denominator to 0 and solve for x. And so, setting each factor to 0, I have x is equal to 7, or x is equal to negative 2. So the domain is the interval from negative infinity to negative 2, and from negative 2 to 7, and from 7 to infinity. Okay, so that's the domain. B. What are the vertical asymptotes? Well, vertical asymptotes are what we just found above. X equals 7, X equal -2. So those are my vertical asymptotes. C, what are the horizontal asymptotes? Well, as x goes to infinity, doesn't really matter, plus or minus infinity actually in this case. And let me just look at the original. I can divide both the numerator and denominator by x squared. So it looks like a 1 plus 3 over x minus 10 over x squared. 1 minus 5 over x minus 14 over x squared. Each of these terms here go to 0 for values of x being large. And so this approaches 1. And so that says that the horizontal asymptote is just y equal 1. So the asymptotic behavior, the large time behavior of this particular function is that it flattens out and it eventually approaches 1 at infinity. D, what are the oblique asymptotes? Well, since there's a horizontal asymptote, I made it so there's no oblique asymptote. So, no oblique asymptote. As x is very large, this tends to a number. It doesn't tend to a higher order polynomial. E, what are the x-intercepts? So to find the x-intercepts, you set f of x, y to 0. So let's do that. So the to figure out when y is 0, just set the numerator to 0. And solve for x. And so x plus 5 is 0, or x minus 2 is 0. So x equaling -5, x equals 2. So the x-intercepts are at -5, 0, 2, 0. So those are my x-intercepts. What's the y-intercept? You can find the y-intercept by setting x to 0. 0 squared plus 3 times 0. Minus 10. Zero squared. Minus 5 times 0. Minus 14. And so you get a negative 10 over negative 14, so 5 over 7. And so the y-intercept is at 0, 5 over 7. G, graph the function. Okay. So 1, 2, 3. 1, 2, 3, 4. Negative 5, 1, 2, 3, 4, 5. It's 0. At 2, it's 0. Asymptotes 7 and negative 2. 1, 2, 3, 4, 5, 6, 7. So those are my asymptotes. And y equal 1. It's your horizontal asymptote. Okay. And so, since it passes through here, I see that my graph should look something like, let's approach this, go through here, and approach that asymptote. Okay. It can't cross here, since there's no 0, and it has to approach these asymptotes. So it's going to look something like this. Huh. Well, good enough. Okay. Okay. And it has to go through here, and at 5/7, which is about here, it has a 0. Okay. So it's going to look something like, well, okay, it's approaching. It goes like this and like that. It approaches the asymptotes. But oh, maybe I'll just sort of exaggerate it then. So it goes like this. There. That's certainly very exaggerated. Well, I just want to show that if it approaches this asymptote. Okay. So more or less looks like that. I've sort of crunched it in. Obviously, it doesn't go down that fast. So the vertical asymptote is, oh, let me just check. Here, wait, the vertical, unless I wrote it wrong. The vertical asymptotes are 7 and negative 2. 5 was, negative 5 was a x-intercept. So the x-intercept here was at negative 5 and at positive 2. These were the intercepts. And this 7 over 5, 7 over 5 was your y-intercept. Okay? Oh, what's it make those vertical asymptotes? Ah, that's where your notice is not part of the domain. That's you set the denominator to 0 and solve for x. So I set the denominator to 0, solve for x. That's also what gave you your domain. So that was also how I found the domain. Um, your vertical asymptotes weren't in the domain. Okay. Um, any other questions about that? Okay. H. Maybe we'll just do H here. Express the range. Range is everything. So if you look at this guy, it goes everywhere. So, oops. So the range of f is everything. Okay, 2. F of x, 5x to the 4, 40, x cubed, 81x squared, 8x plus 16. Okay, so you want to find the zeros of your function. Okay. Let me see. We call it P and a Q, right? Okay. Okay, so um, I think that's what I call it. I think I called that the first one. Okay. Possible values of Q. 1, 2, 4, and 16. Just the factors of the constant term. And so the possible values, I should have called it the other way, because maybe I think we call it P over Q. Yeah, I think we call it P over Q. So this is Q, P. Possible values of P over Q, of the roots. Okay. And so 1, 2, 4, 16, 1/5, 2/5, 4/5, 16/5. Okay, so let's try to find the roots. 5, 40, negative 40, positive 81, negative 8, 16. Let me think for a second. Oh, where's 8? Sorry about that. Sorry. That was a typo, obviously. Yeah, I didn't factor 16 correctly. I didn't put down that factor. So 8. Okay, here, wait. Darn. Okay. Well, there it is. Okay, so 1/5, 2/5, 4/5, 8/5, 16/5. Okay. 81 minus 8. 16. Okay. Oh, yeah, yes, that was a typo. Okay. Okay, so let's try 4. 5, 20, 20, 80, 1, 4, 4, yes. 16, 0. Oh, and that works again. That works even better. Um, 5, 20, 4, 0. Okay, so, and then that's 5x squared plus 1. Okay, so this is equal to, it says find the real zeros. That's it. So the real zeros are 4. Is 4. There's only one is 4. Okay. B. Oh, list the multiplicity of each zero. So first, so I have here 5x squared plus 1 is 0. So I have that x squared is negative 1/5. So one of the roots is x equals plus or minus I 1 over rad 5, or rad 5 over 5. But okay, so list the multiplicity of each zero. So 4. Oh, and determine whether the sketch crosses or touches the x-axis. Well, oh, maybe you should just said list the multiplicity of each real zero, so because the non-real ones don't cross. Oh, so maybe that's what I'll do. So those are the other two roots, but this question really doesn't ask that. List the multiplicity of each zero. So 4 has multiplicity 2. And so it touches the x-axis. So it doesn't cross the x-axis. The other two roots, so the other two roots are complex and do not, well, they're complex, so they don't have anything to do with crossing the axes. Okay, 2, 3. Use the given 0 to find the remaining zeros of the function. So f of x equal x cubed plus 5x squared plus 7x minus 13. One of the zeros, one of the roots, is negative 3 plus 2I. But since all the coefficients of this polynomial are real, then you must have that another root is its complex conjugate, because they come in conjugate pairs. Okay, so let's look at x minus the root negative 3 plus 2I and x minus negative 3 minus 2I. And let's multiply these together. And when I do that, let me group these. So this is just difference of the product of the difference in sum of the two terms is the difference of their squares. And so this is equal to x squared plus 6x plus 9. Again, I squared is negative 1, so this becomes plus 4. So I have x squared plus 6x plus 13. And so let's divide to find the other root. So x cubed plus 5x squared. Or you can guess, has to be plus 1. I can just guess it. So if I look here, it has to be plus 1, because what else could give you or minus 1, what else could give you the 13? Okay, so let's see if this works. X minus 1 times x squared plus 6x plus 13 is equal to x cubed plus let's do it this way. So x cubed minus x squared plus 6x squared minus 6x plus 13x minus 13. So if you do that, you get x cubed plus 5x squared plus 7x minus 13. Okay, good. And so this is f of x. So find the remaining 0. So the remaining 0 is found by setting x minus 1 to 0. So 1. Well, So you set x minus 1 to 0, so x is equal to 1. And so the remaining 0 is 1. 4. Oh, here it is. Okay. F of x equal x over x plus 5. G of x equals 25 over x plus 3. Find the domain. Okay. And so let's look at f composed with g at x. Find the domain of f composed g. Yep. Okay. So wherever there's an x in the formula for f, replace x by the formula for g. So wherever I see an x here, I replace x by 25 over x plus 3. 25 over x plus 3 plus 5. Okay. So let's find the domain. So I have to have that x plus 3 cannot equal 0. And I must have that 25 over x plus 3 plus 5 cannot equal 0 either. Subtracting 3 from both sides, you get x equal negative 3. Multiplying both sides of your equation by x plus 3, you get 25 plus 5x plus 15 is 0. You get 5x plus 40 is 0. So you get x equal negative 8. So the domain doesn't say how to write the domain, so I'll be lazy. The domain of f composed with g is a set of all x, but you don't want it to equal negative 8 nor negative 3. B. Find f composed with g at negative 1. We'll plug in negative 1 for g. You get 25 over 3 minus 1 is 2. So I do f of 25 halves. So we'll have to plug in a 25 halves here. So this is 25 halves over 25 halves plus 5 multiplied by 2. And you can, yep, you can still hear me. Okay, good. Don't know why it said that. So this is equal to 25 over 25 plus 10, 25 over 35, 5 over 7. So f composed with g at negative 1 is 5 over 7. Let me do problem number 5. Find the inverse of the following one-to-one function. Oh, it's just a linear function. F of x equaling 5x minus 8 over 3. Replace y, f of x by y. 5x minus, let's write it. Well, I see why they write it that way. So y equal 5x minus 8 over 3. Interchange x and y. Multiply both sides of my equation by 3. Add 8 to both sides of your equation. Divide by 5. So the inverse function is just 1/5 x. Maybe I'll write it this way. It's just x, 3x plus 8 all over 5. Okay. 6. Find the domain of f of x. Okay, so the domain of a logarithmic function, this is actually base 10. Oh, okay. Sure. Okay. So, if you recall, for a logarithmic function, the function looks like this or like that. But the function is not defined for values of x less than or equal to 0. It's only defined for values of x greater than 0. So the domain is just the set of all things inside of the log which are positive. So I want that x plus 4 over x minus 8 is greater than 0. So let me put this on a number line. Well, let's find the critical numbers. Found by setting the numerator and the denominator to 0. So let's place these on my number line. If x is 0, it's negative, and these have multiplicity of 1, so they alternate, and we want this to be greater than 0. And so we will not include either the endpoints, but it's everything else. Okay. And that is your domain. So the domain of f is negative infinity, negative 4, 8 to infinity. And that is your domain. Okay. 7. Express the following as a single logarithm. ln x squared minus 7x minus 18 over x minus 8 ln x squared minus 6x minus 16 x plus 5 ln x squared minus 18x plus 81. So this is equal to ln. Let me just factor first before I do anything. So x minus 9, x plus 2, x minus 8, x minus 8. X plus 2, at least those cancel, over x plus 5 plus ln x minus 9 squared. Okay, so this is equal to ln of x minus 9, x plus 2 over x minus 8 minus, so you're going to be dividing, so take the reciprocal, so x plus 5 over x minus 8, x plus 2 times, so plus, so times x minus 9 squared. So this is equal to ln of x minus 9 cubed. The x plus 2's cancel. X plus 5 over x minus 8 squared. Now, of course, here it says x is just greater than 0. You actually have to make a few other assumptions, I think, so that these actually work. But assuming everything inside all the logarithms are non-negative, are positive at least. Yeah, because if x is 1, this probably doesn't work. I'd have to actually check. Yeah. So right. So I took the reciprocal of this because there's a minus in front. So that's why the x minus 8 and the x plus 2 was in the denominator and the x plus 5 was in the numerator. Okay, let me do problem number 8. Solve this. Okay, so this is the same as the log. We'll put it as the log base 3 of x minus 5, x minus 11 equaling 3. So the base is 3, the exponent is 3, and the result is x minus 5, x minus 11. So let me multiply this out. So I get x squared minus 16x plus 55 equaling 3 cubed, which is 27. Subtract 27 from both sides of your equation. Okay. Factor. You want two whole numbers whose product is 28 and whose sum is 16. Set each factor to 0 and solve for x. So add 14 to both sides, add 2 to both sides. When x is 2, you have 2 minus 5 is negative. So that's an extraneous solution. When x is 14, x minus 5 is positive, x minus 11 is positive. So good. So your solution is x equal 14. Do problem 9. Oh, okay, now I understand what they're saying. This is 9 halves to the x equaling 3 to the 1 minus x. Okay. It says A, express irrational answers in exact form. Express answer in decimals rounded to 3 places. Okay, so let's take ln of both sides of my equation. And so, let me bring down the x out in front. So ln of 9 halves equals 1 minus x times ln 3. And so, I have x ln 9 halves equal ln 3 minus x ln 3. And so I have x ln 3 plus ln 9 halves is equal to ln 3. So x is equal to ln 3 over, that's ln 27 halves, but I can certainly simplify that much more, but let's say ln 3 plus ln of 9 over 2. Okay, so that's an answer. The same as ln 3 over ln 27 minus ln 2. I like that answer better. It just looks a little cleaner. So it says that's A. B says express in decimal. Okay, let's see if I can do this. Let's find decimal. Oh, I know. I can do it this way. divided by okay, so this is what I get, I think, on my calculator, but I'm going to also 981,384,722,661 to 2 decimal places, 3 decimal places. Okay, let me do this on a calculator. There it is. There's a calculator. So it's ln 3 over ln 27. Three ln 27. Okay. Minus ln 2. Okay, so ln 3 divided by ln 27 minus ln 2. Yeah, whatever. Okay, so I wrote, okay, so it's 422. So that's obviously wrong. Oh, 0.422 106 5 211. Okay, so 0.422. Okay. Yeah, I thought I made an error on the other one. Huh. Okay, 10. Cindy will require $14,000 in 4 years to return to college to get an MBA. How much money should she ask her parents for now if she invested at 12% compounded continuously? Round your answer to the nearest dollar. So A equals PERT. So she requires $14,000 in 4 years, given 12% interest compounded continuously. Okay. So 14,000 PE to the 0.48. So P equals 14,000 times E to the negative 0.48. And so let's see how many dollars this is. So negative 48. 14,000 E, oops, E to the negative 0.48. 8662. 8662, 96 something, or 8662, 8662, 967485. Yeah, I'm pretty sure that was it. So it is $8,663. Okay. So in 4 years, $8,663 becomes $14,000. 11. A culture of bacteria obeys the law of uninhibited growth if 140,000 bacteria are present initially. So I don't know, let's say that we use this notation. And so 140,000 bacteria are present initially. There are 609,000 after 6 hours. And so T is 6. How long will it take for the population to reach 1 million? Okay, so divide both sides of your equation by 140,000. Take ln of both sides of your equation. So you have ln 609. And let me just check. I bet you that's 609 divided by 140. Okay, and then that's I can actually divide that by 7. That's divisible by 7. 609 is divisible. Okay, I can actually reduce that. So divide by 140,000. And you get 609 divided by 140 is 87. 609 divided by 609 divided by 7 is 87. Yeah, 87 over over 20. Take ln of both sides of your equation. So you get ln of 87 minus ln of 20 is 6k. And so k is equal to ln of 87 minus ln of 20 over 6. Okay, so that says that A equals A0, 140,000, E to the K T. I want to figure out how long it will be before A becomes 1 million. Divide both sides of your equation by 140,000. Okay. And so that will be 140,000. 500 over 7. Let me just check. So 1 million divided by 140,000 is 50. 50. over 7. Take ln of both sides of your equation. So you get ln 50 minus ln 7 is 1/6 ln 87 minus ln 20 t. Therefore, t is equal to 6 ln 50 minus ln 7 over ln 87 minus ln 20. How long? And these are in hours. And so t is approximately, plug that in, yes, these are exponential equations. Okay, so it's 6 ln 50 minus, oops, that was almost a bad error, minus ln 7 divided by ln 87 minus ln 20. 8. 6. 8. 23. 0584. So approximately 8 hours. Okay. 12. A cup of coffee is heated to 180. Oh, here, wait. So assume cooling follows the Newton's law of cooling. U equals T plus U0 minus T e to the k t. Okay, so a cup of coffee is heated to 194 degrees. Oops. Yes, but we actually called it, yeah, the answer is yes, but we called it, they're all the same equation for exponential growth and decay, but sometime for money, we call it A equals P e to the RT, but for other things such as growth of bacteria and all that, we say A equals A sub 0 e to the KT. But of course, I mean, it's the same formula. It just happens to be that I have a different notation. Instead of calling it P, I call it A0 instead of R, so K. But obviously, it's the same equation. Okay? Yeah. So just historically, we use different letters, but obviously, it really is the same equation. A cup of coffee is heated to 194 degrees. It is allowed to cool in a room whose air temperature is 72 degrees. After 13 minutes, I like to put the 13 first. The temperature of the coffee is 125 degrees. Okay. Find the time needed for the coffee to cool to a temperature of 88 degrees. Okay, so first let's figure out what K is, and then I'll figure out the time to get to 88 degrees. Okay, so subtract. Let me just solve that. So let me subtract 72 from both sides of my equation. So, and then let me do the 194 minus the 72. Divide both sides of your equation by 122. Take ln of both sides of my equation. And so I get ln 53 minus ln 122 is equal to ln e to any exponent is just the exponent. So divide both sides of your equation by 13. Okay, so you have that u is equal to t plus u0. Oh, that's always going to be the same. E to the ln 53 minus ln 122 over 13 t. Okay, so it says find the time needed for the coffee to cool to a temperature of 88 degrees. And so let's plug in 88 here. And solve for t. Okay, so subtracting 72 from both sides. You do your K. T. Divide by 122. And then divide by 2. Take ln of both sides of your equation. So you get ln 8 minus ln 61 equals ln 53 minus ln 122 t. So t is equal to 13 ln 8 ln 61 over ln 53 minus ln 122. Good, that becomes positive now. Hours. Okay, so let's plug that in. Well, I'll just have to try to guess as much of it as I can. Okay. Oh, maybe I can bring it on the other side. Okay. So 13 ln 8 ln 61 divided by ln 53 minus ln 122. Okay. And that gives me 31. Oh, that's a long time. 31.67. 31.67. 529981. And these are minutes. Oh no, these are just minutes. This is minutes. And so this is approximately 32 minutes. So it takes around 32 minutes for this to cool. Oh, 16 over 122. Hopefully I did that in my head correctly. Divided by 2 is 8 over 61. Yeah. So I just reduced the 16 over 122. I just divided both sides of my equation here by 122. Any questions about that? Got it. Okay. So that finishes out the first set. Okay, so why don't we do this? Let's end the first set, and then maybe we'll do the second set in like an hour or so. How's that? Okay. So I'll finish this recording. Oops.